position every single time. However, factors such as game speed, defenders, and the ball game ensures that the player will not usually have the ideal situation to implement precise physics each time. Nonetheless, physics players must consider angle and distance, along with a seamless combination of sight, form, and position to perfect their shooting ability. Like every projectile, gravity is the only force acting upon it. An object moving vertically decelerates at a rate of 9.8 meters per square second or 32 per second. Because of the influence of gravity, the trajectory of an object is parabolic, thus coming the term parabolic trajectory. Since the object's path is parabolic, we can use our knowledge in quadratic relations and functions to further understand the effects of each factor: initial height, initial velocity, time to the height traveled by a certain object. Today I will be discussing the physics and math behind shooting a basketball to a hoop. In physics, the height traveled by a certain object at a certain time is equated as h of t is equal to 1 half gt squared plus initial velocity t plus initial height, where g is the acceleration due to gravity, t is the time, p is the initial velocity, and h is the initial height of the object. In this case, the basketball, to further understand this, I will give you an example. A basketball player releases his layup shot at 7 feet with an initial velocity of 19 feet per second. Determine the maximum height of the basketball, the time it takes for it to reach the maximum height, the horizontal distance, and the time it takes for it to hit the ground. First, we should get the equation of the parabolic trajectory by substituting. We get h of t is equal to 16t squared plus 19t plus 7.5. To get the time, we substitute the necessary values to the equation t is equal to negative b over 2a. By further solving, we get t is equal to 0.594 seconds. Next, we substitute the time to get the maximum height of the ball. So, we have h of t is equal to 16 times 0.594 squared plus 19 times 0.594 plus 7.5. This will lead us to the answer 13.138 feet. To get the time it takes for the basketball to hit the ground, we simply need to get the solutions for t. Since the height of the object is 0 when it hits the ground, we will substitute 0 for h of t. By using the quadratic formula, we get the following solutions for t is equal to negative 0.325 seconds and 1.5 seconds. Since time should be positive, the solution to the problem is t is equal to 1.5 seconds. Let me give you another problem. A basketball is shot to the ring 3 meters above the ground from the initial height of 1.85 meters, approximately 6 inches. The path of the basketball is defined by the function y is equal to negative x squared plus 2x plus 24, where x represents the horizontal distance traveled in meters and y represents the height in meters above the ground. How far has the basketball traveled horizontally when it lands on the ground, and how long will it take to reach the ground? What is the maximum height of the ball, and at what time will it reach its maximum height? Given that y is equal to negative x plus 2x plus 24 represent the path of the basketball, we simply substitute 0 for y because the height of the ball is 0 when it hits the ground. Then, we solve for x, which is horizontal distance traveled via factoring. Through factoring, we get x is equal to 6 and x is equal to negative 4. Since we are dealing with distance, we will only make sure that positive value for x. Thus, the horizontal distance traveled is 6 meters. Next, to define how long it takes for the ball to reach the ground, we use the formula h of t is equal to 1 half gt squared plus initial velocity t plus height and substitute for the necessary values. Through substitution, we get negative 4.9 times squared meters plus 10 tm plus 1.85 meters is equal to 0. Using the quadratic formula, we get the values t is equal to negative 0.17 and t negative 2.21. However, only positive values of t should be used, so the time it takes for the ball to reach the ground is 2.21 seconds. Finally, to get the ball's maximum height and time it takes to reach it, we first solve for time. Knowing that t is equal to negative b over 2a, we can substitute the necessary values and get t is equal to 1.02 seconds. This serves as the time it takes for the ball to reach its maximum height. Then, we substitute the value of the equation, negative 4.90 square meters plus 10 prime meters plus 1.85 meters, and derive the ball's maximum height, which is 6.954 meters. I hope this documentary has helped you much in understanding both projects, projectile motion and quadratic function. Hopefully, you'll be able to apply this in future basketball games and shoot as much as I do.